Hello and welcome to this tutorial. My name is Frederik Steinmetz for BlenderDiplom.com, and today I'd like to talk about node workflow. I have created this scene here with Blender 2.79, and back then we had different subsurface scattering options than we have today. Just get into rendered view and look at how this looks like. It looks decent, but we can definitely do better. So back then we had Gaussian and Cubic and Christensen-Burley, and all three do have drawbacks, and the drawbacks of Gaussian and Cubic are actually so big that the developers decided to just throw them out and replace them with two different random walk options. So I want to basically, let's connect this actually. I want to change this material setup to use just one shader node, which is the principled shader. And the reason why I want to do this is because I can get rid of all these nodes if I do so. So that's 5 nodes, and let's just go ahead and delete them. I'm going to go out of rendered view because we don't need to render nonsense. Okay, so let's just press Shift A and add a principled shader. So we have exchanged 5 nodes by this one shader. I'm going to connect this, and I'm going to connect the subsurface color. We're going to leave this at 1 because we want to have full subsurface scattering. This is something I almost never did with the old setup because the Christensen-Burley didn't preserve surface details in areas where no light is shining back from behind, as well as random walk does. And there's a couple of other differences and advantages, and if you want to know more about them, we have a very good book to recommend. Wink wink. So while writing this book, we had to make about 10,000 test renders. I'm not exaggerating here. In the course of writing the book, we did at least 10,000 test renders. So we do need an efficient workflow. We did write some scripts which facilitate a lot, but still, in the meantime, while we're testing, while we're checking out the materials before we decide which test renders to actually include in the book, we need to do a lot of testing. And one of the secrets for speeding up your workflow, I'm going to demonstrate today. As I said, subsurface is set to 1. Random walk was the default, so it's still enabled. We're not going to care too much about these, and we're definitely not going to care about metallic and emission alpha and so on, because they have no place in a subsurface material. So let's just have a look at what this looks like in rendered view right now, and you can see it's nice and subsurfy, but the scale is way too big. So the subsurface scattering radius is set to 1.2 and 0.1 by default. So that means it's scattering red at a radius of 1 meter. And this grasshopper is much bigger than it would be in real life, but the legs are very far from being 1 meter thick. So the entire grasshopper is 1.7 meters long. The reason why I do this is hair and depth of field settings and so on, they can look very strange if your object is too small. So when I do my tiny insects, I usually model them a lot bigger and then try to compensate for that as good as possible. Right now, could go ahead and divide all these by 10. So I can actually type in divide by 10 here and then press tab, and we go to the next one. And I'm going to do the same thing and press tab and divide by 10. So now this looks a lot better, but I still have a problem. If I want to fine-tune this, I cannot go ahead and type in divide by 10 3 times or divide by 0.79. This is just not a workflow that is in any way feasible, and this is why the subsurface scatter node came with a scale slider. So I do want this scale slider on my principal node, but I do not have it right here. And also, I have a lot of stuff I don't need on my subsurface scattering shader. That is here. So let's get 2 birds with 1 stone. I'm going to duplicate the principled shader by pressing Shift D. And it's very important that this is not connected to anything, and also that most of the values here are roughly the value that you want. So I want the roughness to be very low because the grasshopper is coated with a waxy thing to make it protect from losing water. And since it's coated, I'm going to set the clear coat to 1.0, and the coat, of course, is very smooth. I also never want any metallic, and I don't care about these. So we should be set, and let's just go ahead and press Ctrl G, and what this does is create this huge list here. So you can see for each input that is valid, this has created an according group input. So it cannot do this with ggx and random walk because those are drop downs and not inputs, but all the others got created. So let's have a look at what we need and don't need. For example, let's start at the bottom because that's usually where the most useless stuff is. The tangent is basically important only if you're using an anisotropic component of your shader, so they can manually control those. You hardly ever use this anyway, so let's just get rid of it, pressing the minus. We do want the normals, the clear coat normals, but we definitely don't want a transparent component in our shader, so let's just delete this. And you can see it always jumps down, so let's start here. The IOR is simply for transmission. You can see we have a subsurface IOR up here, we do need that, so let's just press minus until all these components are gone. I really don't need them. And the same goes for the anisotropic. We don't need those. Sheen can be very nice. Specular tint can help. And I think that's about it. Okay, since my models almost always use the same map for subsurface scattering and base color, in this case it actually wouldn't matter at all because we have a subsurface value at 1, but in case at some point we do want to lower this again and mix back the original in order to compensate for an eventual waxy feeling, we can go ahead and connect the base color. So what I want to do is delete this one and just use the base color for both of them. So now we can mix them freely, and since this is now not the base color anymore but both colors, I'm just going to label it color by either control clicking or double clicking in this field and just renaming it. This is great. We now have a much smaller node. Compare this. There we go. So much fewer inputs, and actually we don't need the metallic component either. So saved another input there. And if you're sure you're going to use the default values for all of these, then you can, in every material, or at least use the same value in each material, you can always go ahead and delete this, and then you can type in your default value. For now, I'm going to press Control, Alt, and right-click drag. That will mute the connection. And if I now were to change this value, it would change this for every occurrence in that node, as opposed to changing it here, which would only change it in this particular material. So let's go back and connect these. I'm just going to do this, and I'm going to delete this one, and I'm going to connect these, and now we can see much better, but we have the same problem, of course, because we didn't change anything about it. This scale is way too large. So let's recreate the scale factor that we have natively in the SSS node. I'm going to press plus, and it's a good idea to have the subsurface selected at this point, and that is simply because the new input will be created right below the one that you had selected when you pressed plus. So now they have the same name, which is not good. And I'm simply going to double click or control click, call this scale. And of course the scale has no connection here, so we need to do just a tiny bit of math. We're going to add a Shift A converter vector math, and we're going to set this to multiply. So now, as I said, we can either take all the radii and divide them by 5 or multiply them by 0.2. That's the same thing. Or we can just use this one scale slider and multiply the entire vector by the scale. If you use a gray input, gray is a single value, and connect it to a vector value, it will do the same thing as if you were connected to a color. It will use the same value as you provide in the input and use it for x, y, and z. So since the multiply is not a, let's call it a true math function or operator, it will just multiply each x of the upper vector by each x of the lower vector, and so on. And since the xyz is the same for each component in the lower vector, it will multiply our incoming vector, which is the subsurface radius, by the scale factor. So that's much easier. And all I need to do is put this multiply node in the path of the radius to the subsurface radius, and now I have a scale slider. You can see right now it's at 0, and it can go from minus infinity to plus infinity, which is not what I want. I do want a very small value as the minimum, but I don't want it to be able to reach 0, simply because a radius of 0 will negate any subsurface scattering effect, and if I actually want to do this, I could just use the subsurface slider. So I don't want this to go down all the way to 0, I want it to go down to this at most. And the maximum, I'm pretty sure we're not going to need anything above 0.3, and even if we do, we can always go back in there and change that. And the reason why I'm limiting this range is because it makes the slider less sensitive. We're probably not going to use anything above 1.03. So if we had a minus infinity to plus infinity and we dragged, we would use a very, very coarse step size. So by doing this, our step size is much more smaller. So if I drag this, you can see we're going in steps of 0.03 or 5. Much better than with, for example, this one where the step size is 0.1. So much easier to handle if we use these. Another advantage, at least in my eyes, is now the radius is exposed, so you don't have to click on the radius in order to see the values. I like this much better, so now it's exposed. Even though we have a few more inputs now, I still like this a lot better. So let's take our original bumps. This goes in the normal, this goes in the clear coat normals. Now we can press Shift Space and look at our grasshopper. Now the subsurface scattering effect is not gone. You can see in the very thin parts you can still see it, but since the scale is very low, we can safely increase this a lot. And now you can see we have recreated the scale option of the subsurface scattering node, and it's working like a charm. The color here is very red, and that is because we divided all these by 10, but actually I changed it back just for the red channel while doing my test. So this is the default, and it actually looks a lot better. The default settings for the principal shader will of course be for human skin. So these values here loosely correlate to the scattering radii which a human skin would have, and that's a little too red for my taste. So grasshoppers don't have the thick red liquid that we call blood, they have a much brighter liquid, so the subsurface scattering comes mainly from the cuticle and the waxy component of the skin. So this is actually too red. So I could now go ahead and say this is too red, so I'm going to lower the red, and that actually that already worked pretty well. But let's just say I want a completely different color and I don't want to adjust RGB all the time. remember that when we plugged in our scale, which is gray, into the blue, which is a vector which has 3 components, while the scale gray only has 1 component, Blender automatically picked all these values for X, Y, Z, so we can safely do that. And we can do the same thing interchangeable with color. So for example, if we use a combine XYZ node and a combine converter combine RGB, and I'm just going to copy over those values, Control C, Control V, Control C, Control V. And now let's preview this. I'm going to hold Control and Shift and connect this node, which only works if you have the Node Wrangler enabled. Same thing. So actually we only need one of these nodes. It's just for, I guess for overview's sake, combining X, Y, and Z does the exact same thing as combining R, G, and B. So why would this be an advantage then? Well, let's just use an input RGB node and connect the color to the subsurface radius. And we also have to reconnect this, and now you can see it's bluish. And now the big advantage is we can actually just go around the color wheel and in real time see what happens. So instead of changing all the radii by hand, we can just go around the color wheel, and we can always drag this up to make it brighter. And at this point we actually could use the color as the scale. You can see this loosely correlates. So I have this orange subsurface color and it correlates loosely with the orange. So this is has too much green in it, just a touch. So I'm going to walk it towards red. There we go. That's a tone I like. And you can see this is now much easier to control than actually having to control all 3 values. And one little secret for the end, if you actually do need values greater than 1, you can always type them in here. So if you read that the subsurface scattering red of human skin is 3.6, which it, for some complexities, yes it is, you can just type in 3.6 and it will remember this. And since clicking here only changes the ratio of the colors but not the values, just the ratio, you can see now your values range from 0 to 3.6, and that's because that's what we typed in here. So you don't even destroy your whiter than white story by using the color wheel. It's the same effect, by the way, except for here we can type in the values. You can use this freely as vectors as you would with any other vector, but it's much easier to pick from. So now we have 2 methods to modulate the scale, which one is being this one. But if we want to really go overboard or underboard, for example, if I use, you can see we have a tiny scale here, which is 0.26, and if I wanted to go down to 0.26 in the value 0.026, we can see that's very dark and we can't really see what our colors are anymore. So having 2 scale options is actually very nice. And you can see the further I drag this out, the more saturated, more tinted our subsurface color is. You could leave the radii at 111, so the ratio would be 111. But this will only work with the random walk distribution. If you choose any other random walk fixed radius or Christensen-Burley, they will look fairly weird because the random walks also takes into account the subsurface color. The others 2 don't. I don't want to get too far into this. I'm just saying there's a couple of different methods that we can use to modulate, and especially to modulate more easily our subsurface options. And one last thing, I can use this to rename the node. If I just click in there, and I could call it special subsurface scattering. And now if I want to use this in any other material, I can just use Shift-A, group, and use my special subsurface scattering, and it will come in here with the default values that we specified in the group. Scale apparently does get chopped off. Our default of the scale is 0.0. Okay, the default was 0 and the minimum was higher than the 0, and I guess that kind of confused cycles. Let's press tab and delete this, insert it one more time, special, and now we can see the scale has its default of 0.001 and all the other values are there as we want them, and the ones we don't need are actually hidden. You can of course also hide the sheen tint and the specular tint if you want to make things even more easier to find. But this is a, I think, a good compromise. This node still offers you a lot of options, but hides the one you definitely don't need. I'm not going to worry too much about this vastly overdone normal map and all that stuff. That is a tutorial for another day, since this is only supposed to show you the workflow. And let's call them cheats, because you can see here we are connecting a yellow field to a blue field, and that actually makes the noodle or the thread change color to indicate that this is weird. But don't worry, it's absolutely fine. The way Cycles works internally is by color anyways, and as I showed you, there's no difference between RGB and XYZ when it comes to Cycles. Alright, that's it. Got pretty long actually. I hope you learned something useful, and as always, thank you for watching, and please do try this at home. If you want to learn more about how and when to use subsurface scattering, or actually want to learn more about how to use any node in Cycles, I'd recommend our book. We've recently updated it to Blender 3.0 and Cycles X, so if you're using Cycles materials at all, this book is a must-have. Thank you.